Hello and good morning. Today we are going to go into synthetic division. So yesterday, hopefully you were able to practice long division. Synthetic division is just another method for dividing polynomials. A lot of people think it's a lot easier, but make sure you've tried long division before you get into this section today. So yesterday you should have done the 2.3 worksheet, just the front where it says to use long division. Today you will finish that worksheet. You'll do the back of it where it says use synthetic division. Okay. So in using synthetic division, instead of doing our long division box that looks like this, we're actually going to make it upside down so that it looks like this and it's a little bit longer. We're going to put a little, well, let's do this. So if we look at our polynomial that's being divided, we need to get the coefficients of this polynomial only. So if I remember, a coefficient is the number in front of the variable. So like in this middle term right here, 4 is the coefficient. On this first one, since I don't see a number in front of x squared, it would just be a 1. So across the top of my box, I'm just putting the coefficients, leave a little space between each one. So we have 1 and 4, and then the last one is not exactly a coefficient, it's a constant, but we're going to put that one there too. Let me fix my error here. And so, oh, this thing is a little frustrating. Okay, so we put our coefficients across the top, we leave the x's out, but we do want the signs, any sign that's in front of them we want to keep. The next thing we're going to do is we're going to look at our divisor. My divisor is x minus 1. But for synthetic division, I'm actually going to use the 0 for this factor, or for this binomial. So I'm going to set it equal to 0. I'm going to solve for x. And so I see that x equals 1. So 1 is the 0. I'm actually putting the 0 right here in the front. I'm going to put a box right here underneath the last number across the top. That's just going to be where my remainder is. If there's a number in that box, it's going to be the remainder. So I'm going to drop 1, the first number, whatever it is, straight down, no changes. And then I'm going to take my 0 over here and this number that I just brought down, and I'm going to multiply them together. So 1 times 1 is 1. Put it in the next column. Then I'm going to sum this column. So I need to add these together. So 4 plus 1 is 5. And then I do the same process again. I look at my 0 and I multiply it by the number that I just got when I summed that column. 1 times 5 is 5. And then I sum this column. So I'm going to add negative 3 plus 5, which is equal to 2. So now I'm done. I have my remainder in the box here. I know it's 2. Now I need to write down the answer. And to do that, I need to look at my original equation that I was dividing. It's x squared plus 4x minus 3. And I just divided it by x minus 1. So I divided one of the x's out of x squared plus 4x minus 3. So my answer will be 1 degree down of whatever the highest degree is up here in my polynomial. So in other words, I will just put x to the first power after 1. And since it's 1, I don't actually have to write the 1. I could write the 1 right here if I wanted to. If they're positive, I'm just going to put a plus between. If they're negative, you put a minus. And oops, I just said to the first degree and then I wrote a 2. It should be to the first degree. So I'll get rid of that. All right, so 1x plus 5. Since this was to the first degree, this one shouldn't have an x with it. And then 2 is my remainder. So I'll add that on just like I did with the long division. And I need to put it over the divisor, which in this case was x minus 1. This is actually the same problem that we did yesterday with long division. We're just doing it with the synthetic division. So our answer is x plus 5 plus 2 over x minus 1. So that one, I didn't really need to write it, so I'm going to cover it up with my circle here. So that's the solution. So let's try another one. All right, so on this one, I have 5x squared minus 1 divided by x plus 1. So again, I'm going to draw my upside down division box here. I'm going to put the coefficients across the top, but remember, when we're dividing, we have to have our exponents going down by 1 each time. And on this particular, oops, on this particular equation, we have no x term. And because of that, we have to think of this as 5x squared plus 0x minus 1. Wow, this pen is giving me stress. 5x squared plus 0x plus 1. So I will need to put a 0 in here as a placeholder for that x term that's not there. And then minus 1. I'll put my box under here. That's going to have the remainder in it when I'm done. And then out front, I'm going to put the 0 from x plus 1, which would be negative 1. So negative 1 goes here. I'm going to drop 5 straight down. No changes. I'm going to multiply negative 1 times 5 and put it in the next column. So that would be negative 5. I'm summing this column. So 0 plus negative 5 is negative 5. Then negative 1 times negative 5 is positive 5. And negative 1 plus 5 is 4. So again, I'm going to look up at my original equation. It's squared. So I know that this first term here is going to have an x to the first degree on it. So that would just be 5x. The next one won't have an x. And then plus 4 over my divisor, which was x plus 1. Okay, so there's the solution. All right, let's try another one. We'll just do a couple more examples. All right. So upside down box, my coefficients 2, 7, and negative 15 are going to go across the top. My remainder will be under that last number. I want the 0 from x plus 5, which would be a negative 5. And I'm bringing the first number straight down. So 2. So negative 5 times 2 is negative 10. 7 minus 10 is negative 3. And then negative 5 times negative 3 equals 15. And negative 15 plus 15 is 0. So this one has no remainder. The original was a second degree, so I'm going 1 degree down for that with my x that I put here by 2, which would be x to the first degree, and then minus 3. So with no remainder, that's just the answer, 2x minus 3. So what that means is if I were to take 2x minus 3 and multiply it by the thing I just divided by, right, by x plus 5, okay, if I go ahead and multiply this all out, then it's going to equal that, right? So think about that too. All right, so last example, we have 3x squared minus 4 plus x to the third divided by x minus 1. Again, another example that we did yesterday, but we're going to do it with synthetic division. The first thing I need to do is get organized with this equation because it's not in standard form and there's an x term missing. So I'll write it as x to the third, the one with the highest exponent first, then the second highest, which would be plus 3x squared. I don't have an x term, so x, the first power is missing, so I'm going to put plus 0x and then minus 4. So now it's in standard form, so now I can draw my box and get those coefficients. So if I don't see 1, it's going to be a 1, right? So 1, 3, 0, and negative 4. Put a box underneath the last one. That's where my remainder is going to go. And then find the 0 for my divisor. So that'd be a 1 out here. Bring the 1 down, multiply them together, and put them in the second column. Add this column together. Multiply 1 times 4. Add the column. Multiply 1 times 4. And add the column. Again, no remainder. All right, so our original polynomial was degree 3. So my answer is going to go down 1 degree. So this 1 right here would have an x squared after it. Then the 4 would have an x. Hold on, just 1 second. Let's get rid of our weird line. So x squared minus 4x plus 4, and with no remainder, that's just our answer. All right, guys, hopefully now you can finish the back of that assignment. If you have any questions or any problems with it, you're welcome to email me. We can get together in a chat and we can get your questions answered. So just hang in there, guys, and have a great day. Talk to you later.